My final project topic is on a product called OpsCode Chef. Let me start with an overview. What solution does Chef provide? Chef provides an additional layer in between the cloud and the infrastructure that creates a one-stop management interface. It is platform independent and provides increased flexibility to the enterprise consumer. The hosted enterprise server directs the child nodes using scripts, security policies, and custom configurations that ultimately create a large environment in an organized fashion. You can manage many different nodes over many different offerings very quickly. It is not a problem to use an AMI from AWS and connect to an image from Azure or even from your own local data center. One of the things that we encountered in class with AWS was differences in available AMIs between availability zones, and this is another thing that Chef resolves. But it is bigger than that. It is also about customizing configurations for deployment in a way that allows the user to have very little interaction with setting up a server or more than likely a cluster. Just pick your pre-configured customization and go. In Chef, these are called cookbooks. Cookbooks are plugins, source code, security settings, and are housed in repositories. They are set up in a way that makes it so that you don't have to start from the beginning, and you can share someone else's concept, or more often than not, make a common task easily repeatable and get consistent results. Git is their preferred source, and it makes many resources publicly available to make your life easier to get started. Chef is programmed in Ruby, but it is configured in a way that makes your Ruby knowledge requirements relatively small, at least to get the system going. Of course, the more you make your task heavily automated, the more advanced programming will be required. I was able to get Chef up and running in about a week. There are quite a few steps to get all of your security details in place, and they are not immediately intuitive. One of the difficult tasks is finding resources that truly break it down step by step for the beginner. You really do have to tinker quite a bit. While the cookbooks are the overarching management tool, recipes are the specific task that you are trying to accomplish. You need to get very granular with your development of an environment, and this is the way to do it. Recipes configure every specific detail of your build. They are added to the run list of the Chef client. There is a Chef-specific API called Knife. Knife provides a command line process that allows instantiation of many nodes using specific recipes. This will allow the system admin to create powerful scripts that will automate some of the routine tasks in his environment. It provides management of security settings from all platforms. You can spin up clusters and specify roles. Knife has a number of plugins and interfaces that allow you to use it in any desired workstation level platform. So even though the core of the API is command line driven, it does not need to feel that way to the user. Knife is required to be on all servers and workstations that would like to interact with Chef. This may be considered a drawback in comparison to other offerings like Chef, and this led me to doing a little further research on Chef's competition. Here's my configuration file, and as you can see, it is not that difficult to add the additional layer of security settings to pass through to AWS. This requires a number of Ruby gems to be installed, but once you have everything set up, it is seamless. A couple of the questions I asked myself when taking on this project were, what are the choices out there? And is Chef the best? There are a number of competitors, and I will just quickly breeze through a few and give a high-level comparison. Puppet is the most like Chef and arguably is more mature with their offering. Puppet represents the whole picture of data center orchestration, encompassing just about every operating system and offering deep tools for the main OSs. Initial setup is relatively simple, requiring the installation of a master server and client agents on each system that is to be managed. It also uses Ruby and a proprietary CLI called Puppet. Ansible is based on Python and is mostly SSH driven. Ansible does not require an application-specific service and is mostly driven using the command line interface. It is a small package and is very flexible. Salt's biggest advantage is its scalability and resiliency. You can have multiple levels of masters, resulting in a tiered arrangement that both distributes load and increases redundancy. Upstream masters can control downstream masters and their minions. Another benefit is the peering system that allows minions to ask questions of masters, which can then derive answers from other servers to complete the picture. So one could argue that a small environment does not need this level of hand-holding that these products offer. In AWS, I could just create a few core AMIs and launch them on my own, even in clusters when needed. I can still configure auto-scaling, and there are plenty of options using its command line tool. Apparently, the makers of Chef are aware of that. When you look at this pricing chart, you can quickly see that this does not cost a significant amount, and if it makes life easier, then it is something worth considering adding to your toolkit. However, when you get into these larger mixed environments and you are using many different offerings, you can't help but see the usefulness of one management tool to rule them all. And in the big picture, Chef is a pretty solid option.